Right, here we are with the third assisted lab, assisted lab 3, intercepting and interpreting network traffic with packet sniffing tools. So in this activity, you will use Wireshark and TCP dump to capture network traffic and display relevant information on the local network. Interpreting the output from such captures is useful for security assessments. Use the Kali Linux virtual machine to capture some network traffic and identify the main features of the Wireshark network analyzer. You'll assume that Kali has been able to obtain some sort of network tap, which has been simulated for you already by configuring port mirroring on the Hyper-V switch. So here we go. Make sure that we are in PT1 Kali. We are. We're going to log in with root. And the password is that one there, ROT, capital P-A, $, W0RD, enter. And from the desktop, we're going to select the Wireshark application. There you go. Maximize the window. There we go. See all kinds of stuff there. Under Capture, select ETH0 adapter. Pick that one. Okay, where is it at? We don't have an ETH0. Oh, it's already selected. Okay. Didn't see it. In the capture filter box, type IP. Okay, so just IP. The IP filter captures IPv4 traffic, not IPv6 traffic. So that's good to know. There are two types of filters. Capture restricts which frames the sniffer records, while display filters, but does not discard what has been recorded. The syntax of capture and display filters is different, and capture filters are more basic. So we're going to start the capture by selecting the blue Start Capturing Packets button in the upper left corner of the Wireshark interface. It's this guy right here. Start. Come on now, start. Let's do it again. Start. There it goes, finally. So on the PT1 Kali VM, launch Firefox from the menu and then connect to this IP address. So let's go ahead and do that. Come up here. Come on now. There we go. And we want the IP address http://10.1.0.2. That happens to be the MS1 Windows web server. Go. All right. So Wireshark is right now capturing the things that we're doing in Firefox. As soon as the 515 support web page is displayed in Firefox, switch back to the Wireshark application. Come back down here. Where's it at? Okay. Back up here, and there we go. We are capturing. In this task, you are capturing packets on the PT1 Kali VM and connecting to the MS1 web server from the same PT1 Kali VM. Capturing traffic on a client computer as it is attempting to connect to a destination computer might be useful in both security and network troubling scenarios. So it's actually still working right now because we have Firefox still open. So now we're going to select the stop button on the toolbar to end the capture. Let's come back over here. That's the stop button. Stop. All right, so we're done capturing. Select any DNS frame, they are color coded as light blue. Anyone, not about that one. And then observe the frame contents displayed in the middle panel. That's here. Wireshark splits out the successive headers and payloads to decode each protocol. By frame, you get frame. This shows information about the bytes captured. 76 bytes on wire, 76 captured. Then you got Ethernet 2. This shows the frame type, the data link layer, which is layer 2, and the source and destination MAC addresses, which is interesting. Note that the first part of the address, the OUI, is identified as belonging to Microsoft. That's the source, Microsoft. Is identified, right? All the VMs are using MS virtual adapters, Microsoft virtual adapters. The last piece of information is the type of network contained in the frame. There's the destination. Okay. Then you have Internet Protocol version 4. We got the source and the destination here. This is the IPv4 datagram, notably showing the source and destination IP, which is a layer 3 address. Note there is usually also a GeoIP function in this section, but as these are private addresses, they cannot be resolved to a particular regional registry or ISP. Let me keep looking here. The next one is User Datagram Protocol, layer 4. Source port, destination port. This uses either UDP or TCP. The most significant fields here are the source and destination ports. UDP port 53 is the well-known DNS server port. So we know that is the DNS server. And then domain name system. It's the last one here. Depending on which frame you selected, you may be looking at a query or at a response. So if you look at this one, all these are queries. Yeah, all of them are queries. Oh, this one happens to be a response. So it shows you. Here we go, query. Just clicking on the different ones. Select the TCP frame that opens the connection to the web server. The first frame that is colored green. So let's go back up, and find the first green one. There we go, that one. And then examine the middle panel. Be sure to note both the source and destination port numbers. What do we see here? Source, I'm not seeing any port numbers on here. Use the Wireshark interface to answer the following questions. Oh, the TCP frame. That's the first green one, it said. These are all TCP frames there. Let's get this one. There. All right. This is better. Now we're seeing the ports here. In the Wireshark interface, what is the name of the layer where the MAC addresses are found? Hint, this info is in the middle pane of the interface. Then frame. No, it's here, isn't it? Ethernet 2. Okay. That is correct. Oh, I missed some. It says I missed some. I don't think I missed any. All right. So also here you can take a look. See, here's the MAC address. Here and here. There's the MAC address. Here's the MAC address. Those two right there. The purpose behind assisted labs is to confirm your knowledge, blah, 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 blah. You do not need the correct answer to move forward. Okay, in the Wireshark interface, what is the name of the layer where the IP addresses are found? Where are the IP addresses found? Well, it looks like it's here, Internet Protocol version 4. Because there's the source and the destination. Yep, and if you wanted to make sure, you just click this one and it shows you. You can click on this and make it bigger too. More information. Yep. Down in the Wireshark interface, what is the name of the layer where the source and destination port numbers are found? Well, they're right here. Source port, destination port. It's in the transmission control protocol. There it is. There's the information there. We're going to close or minimize Wireshark. Let's go ahead and just minimize it. Down you go, boy. There it is. Now it's down at the bottom. We can open it again if we want. Or at the top. It's at the top. And Kali. Right. Use TCP dump to intercept HTTP network traffic. All right. So TCP dump programs another protocol analyzer, packet sniffer. In this activity, we're going to use TCP dump to intercept HTTP traffic. So we're going to switch to the MS1. There we go. We have to do Control-Alt-Delete to get in. And it's already set up with this username. And here we go with the password. With this, we can click on that password. Yay. Press Enter. So the MS1 virtual machine is hosting a website that will be used as part of the packet interception activity. Okay, so we are in the server manager right now, and we're going to select Tools, Internet Information Services Manager. Up here, Tools, IIS Manager. Click on there. We're going to expand the MS1 and Sites nodes. Okay, MS1s and Sites nodes to display the default website node. There it is. Double-click the authentication applet in the default website homepage. There it is, authentication. We're going to double-click that guy. Now we're going to select anonymous authentication, and then from the actions pane on the right, disable. Okay, so it's enabled right now, so boom, right there. We clicked on it. We just go disable. Okay, now it's disabled. Okay, now we're going to select the basic authentication, and then we're going to enable it. Basic authentication, which is disabled right now, we're going to enable it. And there it is. Note the alert. Ignore it for the purposes of this activity. We don't care about you. So now we're going to switch to the other one, to the Kali VM. Yeah, and we are signed in from the menu. So we're going to go to the terminal, which is this guy up here. We're going to do a little Linux command line stuff. All right. And we are signed in as root. That's good. Then we're going to run the following command to begin intercepting MS1 HTTP network trafficking using TCP dump. TCP dump does it in command line. This is good to have and know how to do just in case you are in a command line only Linux distribution where there are no GUI. There's no user interface other than command line. So that's what TCP dump is going to do. So here we go. So TCP dump, TCP dump, that is the command, space. Here is very verbose. Okay, so we got the destination is 10.1.0.2 and port www. All right, so then we got that. Keep going. Okay, so we're going to write. So this is, we're writing to a file that we're calling www.pcap. Let's make sure that I've got it all right, because get one little mistake in Linux and it's not going to work. So TCP dump dash, very verbose, destination 10.1.0.2 and port www, and they're going to write dash w to a file that we're calling www.pcap. Okay, enter. So we're not really going to be seeing anything at this point. You will not see captured frames in the terminal output. The W switch directs output to a capture file that we have named www.pcap. Okay? But we got to give it something to capture. See, we've got 0 right here because we're not capturing anything. So we're going to go the top menu. We're going to go back here. We're going to start Firefox again. Actually, I got that. There, it's open right now. And connect to the website. We're there. Okay. We were not prompted to do anything. If not, press F5 to refresh the page. So I got to make sure I clicked in here. F5. There we go. And it's asking for the username, which is 515 support. Okay, there it is. It just didn't like it. T. It took a second. And then backspace, not forward slash, backslash, administrator, tab, capital P, A, $, W0RD. Okay. Looking okay. Okay, come here. Okay, come here. Come on. There you go, mousy. Switch back to the terminal window and then select Control C to stop the capture. So we come back over here. See, it got 15. Okay, right? So I'm going to click in there to make sure that I'm in there. Then press Control C. Stopped. Stopped it. Okay, 15 packets received by filter. 0 packets dropped by kernel. And kernel, for those of you that haven't taken Linux yet, that is the heart, soul, mind, brain, everything of the Linux operating system. We did that, and we did, okay, so now we did that. Now we're going to switch to the Wireshark application. We did not close the program, so we just need to come back over here. There's Wireshark. We know that because it's got the little sharky fin. Okay. And now we're going to go to the file and open and select www.pcap. That's one that we just did. There it is, see, because we just created it. Okay. And then select open. Continue without saving. All right. The TCP dump files are not stored in a human readable format. So if we went in and catted that, and I might do that just for the lulz. Those who've taken Linux know what I mean by that. We're going to cat it, and we're not going to be able to read it. It's not going to make any sense at all. Applications such as Wireshark can be used to display the contents. So we're going to select one of the get HTTP messages. Here's one. From the top panel, with the get message selected, in the middle panel, expand hypertext protocol. Okay, let's get this one. Okay, take this one so it's easier. Hypertext transfer protocol. Then expand authorization. Where are you at, authorization? All I'm seeing is get. I'm not seeing authorization here. Let's find a different one. There we go. Let's try this one. Let's go down. Close this one. I'm not seeing authorization here. Oh, there it is. Okay. Boom. All right. Ah, see what we have here? This is good. Remember, because it captures. It captured everything. It captured all of my keystrokes and everything. So what did it did? What did it do? Look at this. Credentials. I typed in 515 support / administrator, and there is my password right there. So you can see how TCP/TUM and Wireshark are very, very powerful tools. And yes, hackers and people with bad intentions, they use them. Right. So which of the following options shows how the authentication information is displayed? Credentials, admin, password. No, it shows, right? Credentials, 515 support / administrator : password. It's this one right here. Yeah, credentials are not displayed because they are encrypted. No, this website was not encrypted, so therefore we can see what the credentials are. HTTP packets are unencrypted and therefore vulnerable to packet sniffing. Now we're going to use TCP dump to intercept secure shell network traffic. Oh, this is what I want to do just for the walls. Hold on, just for the walls, so that we can see. Let's come back over here. Okay. Let's do CAT means we're going to look at the file. Yeah, there's nothing to see here. See? Oh, where'd it go? Yeah. It's not readable. We can't read it. There we go. That was just for the walls. Alright, so now we're going to use TCP dump to intercept secure shell network traffic and attempt to display contents of the traffic. Again, for those who have not taken Linux, secure shell, you're probably familiar with PowerShell in Windows. Secure shell is like PowerShell. You will use secure shell connection to this IP address. This address is assigned to the LX1 virtual machine, which runs the CentOS 7 Linux distro. Alright, so we are in Kali. Let's come here, let's just make that small. Make it small. Go small. Go small. Thank you. Okay, so we are going to go in, okay, so we need to go back. Run the following command. We need to open the terminal back up. Okay, because we're doing something new, something else, I'm going to type in the clear. By doing that, it takes everything off and we can start with something new. Alright, so now we're going to do TCP dump, very verbose. The destination is 10.1.0.10. Okay, so TCP dump, right? Dash, very verbose. The destination is 10.1.0.10 and port SSH. Okay, the port is the SSH port, the one that is for secure shell. And which one is it? I think it's 43, isn't it? Oh. Okay, you come back over here, then press space, and then we're gonna write the output to a file that we're calling ssh.pcap. Make sure I got it right. TCP dump, very verbose, destination is 10.1.0.10, and the port we're using is secure shell. We're going to write the output to secure ssh secure shell.pcap. Did I get it? Yes. All right, there we go. Now we're going to open a second terminal window. All right, so just open another terminal. And now we got two of them going. All right, one over here, one over here. All right. And then we are going to actually log in, secure shell logging in. We're going to log in as root. There, okay? So SSH using secure shell to log in as root at 10.1.0.10. It's going to ask for the password. Yep. Cannot be established. Are you sure we want to continue? Yes, we do. Okay, to confirm the connection. And now we need the password for root for this one. And they're going to give it to us, which is capital P A. Oh, let me make sure I'm in here and press backspace. Because sometimes with this, it's not going to show you anything. So capital P, yeah, not anything. A, $, W0RD, enter. Okay, so don't freak out if you're typing and stuff and you're not seeing anything there. Sometimes Linux will do that. Okay. Yeah, click here if you're unable to enter the password. Yeah, so it does. It'll show you Linux terminals will not print characters when typing a password. And so sometimes it can say, well, I kept on doing it. Yeah. So now we're going to run the hostname and whoami commands to confirm that you are the root user on the LX1 remote system. Okay, so I'll just hostname. Okay, so yeah, so we're lx1.corp. So we're there, and then the who am I is going to tell us that it's root. Who am I? We are root, right there. Is it telling you you are? Okay, so now we're going to exit. I'm going to come in here and type exit. Boom, and it's closed. Okay, so now we'll switch to this other one. Oh, it got 672 there. Let's make this one small. I don't think we need this one again. But let me minimize it. There we go. So we're over here. Click inside there and make sure you're there. Control C to stop. 72 packets captured. 72 received. 0 dropped by the operating system. So now we're going to go back to Wireshark. I still have it open. Yep, but we have they have the www.pcap. So we're going to go ahead and we're going to switch. So we're going to go to File. Oh, back over here. File. And Open. Okay, scrolling down. There's the new one right there. And open it. All right. Yeah, the same thing we just did. Now we're going to spend a few minutes browsing the captured information. Now let's see if we can find any credentials. Let's see, anything with a get on it. I'm not seeing anything. Oh, encrypted packet. So it's not going to tell us anything. Yeah, it's not going to tell us anything. TCP. Yeah, it's not going to tell us diddly. Why? It's because everything is encrypted is why. Yes, I do want to extend. Thank you so much. Thank you so much. Any details says the source and destination port numbers, saying at source, destination port numbers, all these. Like, let's get another destination. 22, that's your SSH, is your destination port. That's your secure shell. It's 22. Okay. Were you able to read information about the root user, such as the password? No. Why? Because it's all encrypted. That's why. Now, questions. Which of the following answers best describes the content you viewed by using the TCP dump utility? Well, we looked at HTTP and secure shell traffic. We did not look at HTTPS. We didn't, DNS traffic. We didn't look at the DNS traffic. We only looked at HTTP and SSH traffic. Would an eavesdropper be able to intercept and read the contents of a web page on MS1 if the web server required HTTPS connections. Let's think about that for a second. HTTP secure, which means that it's encrypted. So no, the contents would have been encrypted because you're using secure. Da, 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 da. Let's grade this lab, submit it. Yes, we're sure. And there we go. We done did it.